Okay guys, yesterday we really focused on looking at transformations and just different ways that things can move. Different places in this particular equation that A's show up and what they cause the parent function to do because of it. Okay, so today I really want to get our vocabulary down pat. I really want to get that vocabulary down so we're very confident with our vocabulary. Okay, so look back at last night's homework if you want to for a reminder. But let's talk about what happens. What is the effect on the parent when A is added to X inside the function? Use whatever language you want, appropriate language that you want here. Tell me what happens. It slides left. Okay, so here's what we're going to write. Okay, so that we're all writing the same thing. Fair enough? We're going to write that this is a horizontal shift. Okay, now this is when we start our use of transformational words. Okay, a slide is also correct. A transformation is correct. A shift is correct. If you are going to use this word, just like I just did, please make sure you don't forget your F. It's a completely different word if you forget your F. Okay? Now, we have to decide on direction, though. We said horizontal, but how many directions are there horizontal? There's two, right? There's a left and a right. So what's going to make this shift to the left? So left if A is positive. Positive. Like f of x plus 2, for example. Does that seem weird to you? That it's going to move in the negative direction if A is plus 2? Yeah, you can just get over it because that's what's going to happen. Okay? It's okay. It's all right. So when is it going to move to the right? Right if A is negative. For example, f of x minus 2. Yeah, absolutely. Okay? Where is the x and where is the minus 2, though? That's a big deal. It's inside, right? It's inside the function. All right? We're going to be, when we talk about transformations, we're going to be talking a lot about inside and outside. That's really going to make a difference for us. Okay? So look at the next one. Y equals f of x plus a. How do you think this one moves compared to the parent? Yeah, absolutely. Absolutely look back if you need to. It's going to go up or down. So using this as a pattern, what am I going to write first? Vertical shift. Okay? How many directions are there vertically? 2. Up and down, right? So how is it going to move up? Up if A is positive. Like f of x plus 3. Okay? And down if A is negative. Very good. For example, f of x minus 3. Okay? What about number 3? Thank you for reading it. Yes, it does say y equals f of a of x. Compressed, is that what you say? Okay. I'm hearing a very good discussion. Very good talking points. Very good arguments on both sides. Okay? It does depend, doesn't it? It does depend. Okay, first of all, this is, where is the A? Inside. If it's inside, what kind of thing is happening? A horizontal thing. Okay? So that means horizontal this way, right? So we're going to say a horizontal stretch or compression. Is that what I want to say? Yes. Horizontal stretch or compression. What makes it a stretch? If A is okay, so you're on the right track. I hear lots of people saying if A is less than 1. But what does it also have to be? A has to be less than 1 or greater than 0. I'm sorry I didn't give you a lot of room to write that. Cross it out and write it over here if you need to. It has to be less than 1 and it has to be greater than 0. You're saying the right thing. I'm just correcting your vocabulary a little bit. Is that fair enough? Okay. So it's a stretch if A is between 0 and 1. Okay. It's a compression, a horizontal compression, if what? If A is greater than 1. Absolutely. Any questions about that? Horizontal stretch is you're taking the graph and pulling the ends. It's like you're grabbing the ends and stretching it that way. So what's actually happening to the graph? It's getting flatter, isn't it? Okay? And a lot of people get a horizontal stretch confused with a vertical compression. Because doesn't it actually do the same thing? Yes. It just depends on where that multiplier is, whether it's inside or outside, whether we write it's a horizontal stretch or vertical compression. Does that make sense? Okay. So what about this A? Where's this A? It's outside. Since it's outside, I know what kind of deal is it? Vertical. It's a vertical deal. So what is it here? Vertical stretch or compression. Because it's a multiplier, right? If it's an additive number or subtractive, are those even real words? If it's adding or subtracting to the function, we know it's a shift, right? If it's a multiplier on the function, I know it's a stretch or compression. Fair enough? Okay. So I have my vertical stretch or compression. What makes it a vertical stretch? If A is greater than 1. What makes it a compression? Greater than 0 and less than 1. So, like that, right? Now, is that opposite of what's above that? Yeah, but hopefully you notice these are opposite as well, right? Okay. So what about 5? Say again? Reflection across x-axis. That's actually really close. It's the y-axis, right? Okay. Very good math words, first of all. Very good vocabulary. So we're just going to say reflection across y-axis. Okay, so this crazy kid earlier was like, it's really a reflection over the y-axis. What did I say? I said, okay. Are we going to argue about semantics here? Do you know what semantics are? Word choice? That's not really a semantics issue, is it? They mean the same thing, don't they? Okay. So what about number 6? Yes, reflection across x-axis. Well, we'll keep that crazy kid happy and put over. Okay? So 7 and 8. Are you ready for 7 and 8? Number 7. When you're taking the absolute value of the term inside the function, the x value, here's what I want you to write. For all points on the graph in quadrants 1 and 4, the graph is reflected across the y-axis. All original points in quadrants 2 and 3 disappear. So we have this graph that's like here. All these points in quadrants 1 and 4 reflect over. So these are all still here. They stay here, but they reflect over the y-axis, and the points that were there before are gone. So what do I have? Like a mirror, right? I have a mirror reflection over the y-axis. Anything that was over here before is gone, and just the reflection remains. Does that make sense? I'm going to give you a second just to think about that. Now, are there any questions? You good? Okay. Yes, sir. Because the x points are the ones that are having the absolute value on them. In the same pattern that they were connected before in quadrants 1 and 4. Now we're going to go on to number 8. Okay? Now we're going to go on to number 8. You ready for number 8? All good questions. All good questions. Any questions? Any more? I don't want to skip out on some that you were asking. We're good? Are you lying? Okay. Y equals the absolute value of the function. What points are being affected here? What points were affected here? The x, right? What points are being affected here? The y, right? Isn't y equal f of x? So if we're taking the absolute value of f of x, we are affecting the y value, right? So what's going to happen? What do you think? It's going to reflect across the x-axis. Are points going to disappear this time, though? No. Okay? So for all points on the graph in quadrants, wait, which quadrants are affected? If we're reflecting up across the x-axis, 3 and 4. Good. Quadrants 3 and 4. The graph is reflected across the x-axis. For all points in quadrants 1 and 2, the graph does not change. We're taking like this and we're just folding this up on top of the other stuff. This stays, whatever it was before, whatever was down here just folds up on top of it. Because we're talking about a function, right? We're talking about functions, so is something going to be on top of something else? No, otherwise it wouldn't have been a function to begin with, right? Yay, we're yellow. That's so weird. Any questions about that? Okay. Put that aside and take out the worksheet that I gave you called Traveling with Parents. Consider the parent function y equals the square root on the domain, the square root of x on the domain x is greater than 0. Okay? Some of you, I have to be honest, I laughed inside of my head a little bit on the test when I asked what parent function it was, and there was this sign in the problem. And then you wrote some other parent function besides square root. Why? Or if there wasn't a square root inside the problem and then you said the parent function was square root. Why again? Yay, we're not yellow anymore. I don't know. I'm just being honest. You made me laugh inside of my head a little bit. Okay? So here's a little table that they give us to start off with. So let's get some points out of it. If x is 0, what's y? What is the square root of 0? 0. If x is 1, what is y? What's the square root of 1? 1. If x is 4, what is y? Square root of 4 is 2. And if x is 9, what is y? 3, because the square root of 9 is 3. Okay? So when I plot these points, I have 0, 0, I have 1, 1, I have 4, 2, and I have 9, 3. Okay? Can I connect these points? How do you know? Gave me the equation, didn't it? Okay. All right, any questions about that? What's the range of this function? It already told us the domain is everything greater, all the x values are greater than 0. What's the range of this function? How far down does it go? To 0. How far up does it go? All the way, right? So y is greater than or equal to 0. B. Use a different color to sketch a graph of the family member. Now, we're not talking about your sister or your brother, are we? What family member are we talking about? The function family, right? That results when the parent function is translated 3 units vertically. Negative 3 units vertically. So that means every point on this graph needs to go where? Down 3. How did you know it was down 3 and not left 3? Because it says vertically, right? I need you to know that vertically means up and down. Okay? So this point right here, I'm going to move down 3. This point right here, I'm going to move down 3. I mean, I could move this point down 3, couldn't I? This part of the line, couldn't I move that down 3? Why am I only choosing this one and this one? Right, I know for sure where those are, right? And then this point, 1, 2, 3. Can I connect those? Absolutely. You might not be able to tell, but that's green. Determine the domain and range of this function. What's the domain and range of the green function? How far to the left does it go? And how far to the right does it go? So it goes from 0 to infinity. Is it okay if I use this kind of notation? If not, just get over it and write it this way anyways. What's the other one, just in case? X is greater than or equal to 0. Very good. What about the range? How far down does it go? To -3, right? I know it's not -3 right here where I have my pencil, but the line that I'm saying, how far down does it go, isn't that at -3? So from -3, where? How far up does it go? Infinity. What's the other way to write it? Y is greater than or equal to -3. What's the equation for this new graph? It was a vertical shift. So I'm going to take the original function and subtract 3. What was my original function? Square root of x minus 3. Is it clear that the -3 is outside of the square root? Yeah, don't even draw this line so it's close, right? Okay. Okay, now this crazy kid earlier was like, Mrs. Kingston, the original function said y equals the square root of x. Why did you write f of x equals the square root of x minus 3? What did I say? I said, okay, we can write y instead. Can't we? Okay. In this situation, it's the same thing, isn't it? Okay. So what about C? C says with a third color, sketch the graph of a family member that results when the parent function is reflected about the x-axis. Well, where is this point if I reflect it over the x-axis? Still right there, right? Where's this point if I reflect it over the x-axis? So instead of going up 1 from the x-axis, I go down 1 from the x-axis. This point is above the x-axis 2, so now I need to go below the x-axis 2. This one is above the x-axis 3, below the x-axis 3. You guys are definitely pre-AP, aren't you? So I have my pink function. I don't know if you can tell that's pink, but it is. What do you think? What is the new domain and range of this function? So how far to the left does it go? To 0. How far to the right does it go? So did the domain change? It goes from 0 to infinity. Or x is greater than or equal to 0. Right? What about the range? How far down does it go? How far up does it go? To 0. So it goes from -infinity to 0 and then stops, doesn't it? How do I say this? Y is less than or equal to 0. What's the new equation for this graph? I reflected it over the x-axis, so I've got to have a negative multiplier. Both reflections have a negative multiplier, right? One's outside and one's inside. I reflected over the x-axis, so it is outside. So my new equation is y equals negative square root of x. Any questions about that? Okay, I'm going to get you started on this one, and you're going to finish the rest by yourself. Okay? Let's fill in the table. Here's the parent function. It wants us to use y equals 2 to the x power. What is 2 to the -1 power? It's 1/2. What is 2 to the 0 power? 1. What is 2 to the first power? 2. What is 2 to the second power? 2 squared. Oh, you got that one good. Excellent. 4. And what about 2 to the third power? 8. So plot these. When x is -1, y is a half. When x is 0, y is 1. When x is 1, y is 2. When x is 2, y is 4. And when x is 3, y is 8. Here's something that scared me a little bit that I saw in the test. Can I show you? When people were connecting dots like this, they connected them like this. Like it started here and stopped here. Is that what's happening? It goes above and then it goes that way, doesn't it? Follows the same pattern. Oh, that's an ugly line. I'm sorry about that. That's better. What's the range of this function? Range is down to up, right? How far down does this go? Does it cross the x-axis? No. Does it get to the x-axis? No. So my range is going to be everything greater than 0. Okay? You have B and C to do for homework. Are there any questions? You guys always do this to me. I say, are there any questions? And you sit there and wait till I stop talking and then you come up to my desk. Is it because you don't want to ask questions in front of other people? I'm okay with that. We can work on that. We will work on that. Okay? That's a goal of mine. Any questions that you're willing to ask right now? Yes, sir. We can talk about that in a minute. Okay. Peace.